Hello guys, welcome back to my channel. I'll be solving this question 47. It's from chemistry section in IMAT 2021. So you can also find this from past paper and their website. So I'm gonna be explaining how to solve this question, and it's basically easy. So let's solve this. Okay, so first we have is X is 50 ml of 0.05 mole per liter. This is the concentration, the aqueous solution of nitric acid. Y is 100 ml of 0.05 mole per liter aqueous solution of sulfuric acid. So before we move on forward, we have to note that these two acids are strong acids. And also nitric acid is monoprotic acid, and whereas the sulfuric acid is diprotic acid. So what this means is the monoprotic acid, which is nitric acid, it dissociates and donates one proton only because it has only one hydrogen atom bonded to it. And whereas sulfuric acid, it donates two protons where it has two hydrogen atoms with it. Alright, so we have these two information which is very important. We have the volume and the concentration given. So now it says which of the following statement about these solution are correct. So from these from three statements, we have to find out the correct statement only. So let's go with the first statement. The hydrogen ion concentration in Y, the sulfuric acid, is 4 times greater than hydrogen ion concentration in X, which is nitric acid. So let's prove this by solving it. So now we know that both are strong acid and it completely dissociates. So we should use the concentration of these acid directly to their proton, the concentration of hydrogen. We can directly use the concentration of undissociated acid to the concentration of hydrogen. So this is how we solve. So this is X, the nitric acid, H and O3. So to find the concentration of hydrogen, we know it only dissociates into one proton. HNO3 gives H plus NO3. So we have this one. So it's just one proton. So the concentration of this undissociated acid we know is 0.05 mole per liter. So I'm going to use capital M, which is basically concentration. So we can directly use this concentration and say the concentration of H, the hydrogen ion proton. So the concentration will be also 0.05 mole per liter. Okay. So this is a concentration of nitric acid, and for Y, which is sulfuric acid, will be, we'll draw the formula. So it's H2SO4 gives out two protons and one sulfate. So now we know it has a two proton, two hydrogen ions. We're going to multiply the concentration of this undissociated acid, sulfuric acid, 0.05 mole per liter with times 2. So this will give us H plus 0.05 multiplied by 2 since we have two hydrogen ions dissociated. So we'll get 0.1 mole per liter. So this is a concentration of hydrogen ions of sulfuric acid. So now they said the sulfuric acid concentration of hydrogen is 4 times greater. So we have to find how many times they're greater. So we simply divide the concentration of proton of this sulfuric acid by the concentration of proton of nitric acid. So we oh sorry, so the concentration of H plus of Y, which is sulfuric acid, divided by the nitric acid hydrogen concentration. So H plus, and now we have 0.1 mole per liters divided by 0.05 mole per liter. So this gives us 2. So now we know the statement is wrong because the concentration of hydrogen ions produced by sulfuric acid is actually 2 times greater than the hydrogen ion concentration produced by nitric acid. So now we know that statement 1 is wrong. So now let's move to statement 2. I'm going to erase this quickly. Okay. Okay, so now the statement 2 is only the acid in Y will completely dissociate into ions. Now we know that this Y is sulfuric acid. So in our calculation, we actually assumed that it completely dissociates into 2 protons. But in reality, it does not. It partially dissociates. It's not like in carboxylic acid or stuff, but though it is very strong acid, it actually is strong acid for only first proton. So this is how it is. So for sulfuric acid, H2SO4, for first dissociation, I'm going to use D for short form. First dissociation, the sulfuric acid dissociates into 1 proton and 1 this ion, HSO4 minus. And then in second dissociation, it dissociates this polyatomic ion, the acid HSO4 minus dissociates. But now we're not going to use one single arrow. We're going to use this reversible arrow. Okay, so reversible arrow direction, it dissociates into 1H plus and sulfate. So now from here we can conclude that the sulfuric acid is mainly strong acid for only first dissociation, which is the first proton. But for second dissociation, it's quite weak. Okay, so it has reversible form. So that's reason why the statement 2 is also wrong. But the X, which is the nitric acid, it would be true for it because it completely dissociates into ions like this HNO3 completely dissociates into H plus and NO3 minus. Because why? It's a monoprotic acid, so it directly gives out 1H plus and NO3, meaning it completely dissociates into ion. But for sulfuric acid, it has to undergo into 2 dissociation steps. One in for first dissociation and second dissociation. So the first one is basically the strong dissociation. It's strong acid for the first one, but for second it's quite weak, so it's reversible. So that's reason why this statement 2 is also wrong. So now let's move to statement 3. Quickly erase this thing. Okay, so statement 3 states Y, which is sulfuric acid, has pH value of less than 2 at 25 degrees Celsius. So we know this is basically the room temperature, so no added heat is added. So in room temperature, its pH must be less than 2. So let's find out. So we know the formula of pH is equal to minus log of H plus. So the concentration of H plus ion. So as we said before, because for statement 2 we said that it does not completely dissociate into 2 protons, but in our calculation when calculating pH, we would assume that sulfuric acid would completely dissociate into 2 protons. So in our calculation we would assume this, but when it comes to statement like using in real life experiment, we'd assume that it partially dissociate for second dissociation, but for calculation let's assume it dissociates completely into 2 protons. and sulfate ion. So we also previously calculated, we just directly use the concentration of the sulfuric acid and we multiply by this 2 because we have 2 protons. So 2 times 0.05, the concentration of acid, and gives zero point 0.1 mole per liter. So I shortened it into capital M, molar. Okay. So zero point 0.1 molar, we have this concentration. So this is of H plus. So now we know that it's of H plus, or we can simplify for our ease in calculation, because we know we don't have calculators in labs in IMAT exams. So for our ease of calculation, we just simplify this into 10 to power negative 1 mole. So there's a concentration of proton. So now directly use this pH is equal to minus log. And we basically know whenever we generally use logarithm, we use the base value 10. Okay, so 10 to power minus 1, the concentration of proton from sulfuric acid. So now when we calculate, we know the 10 and 10 cancels out. So now we have 1, power 1, and we know this negative sign also cancels out with this log sign. And now we have pH basically 1. So it's true because this pH 1 is less than pH 2, which the statement 3 states the pH must be less than 2. So we have 1 which is less than 2. So this is correct, statement 3. So in these 5 of given option A is correct. Only 3 statement is correct. So this is it. Thank you guys for watching my video. I hope you found this helpful. So please leave a like and subscribe to my channel. Thank you guys. Bye.